We are back talking about inverse functions today, and today we're going to focus on how to find an inverse. We're going to do this both algebraically by hand and with a graph. So, quick reminder of what inverse functions are. They essentially undo each other by replacing x with y. And the way I can verify if I have two functions that are inverses is when I do composition both ways, I get x by itself as the result. And then remember this f to the negative 1 power, that is our notation for an inverse. And now we are going to follow these steps here to find an inverse when you're given a function. So the first thing you're going to do is if it's written in function notation, f of x, we're going to switch that to y equals. Then we're going to swap x and y within the equation and then use Algebra 1 skills order of operations to solve for y. So we're going to get y by itself, and then we're going to rename that function using our inverse notation. And lastly, use composition to verify that we've done it correctly. So let's start with example A. This is in function notation, so the first thing I need to do is rewrite this as y equals 5x minus 7. And I'm now ready to go to step 2, which means in my equation where I have a y, I'm going to rewrite x, and where I have an x, I'm going to rewrite y. So that's going to be x equals 5y minus 7. Then on with step 3, I am just going to rearrange this equation to get y by itself once again. So the first thing I have to do is add the 7. So I have x plus 7 equals 5y. Then I have to divide everything by 5. And I get that x plus 7 over 5 equals y. So now I'm ready to put that back into function notation. And because this is the inverse, I'm going to say f to the negative 1 of x is equal to, and this is my function, x plus 7 divided by 5. Now to verify that, I'm going to do this over here, step 5, which is verify using composition. I'm first going to plug in my inverse to my initial function, so f of my inverse. That means I'm going to plug this whole thing into x right here. So 5 times x plus 7 over 5 minus 7. These 5's cancel. I get x plus 7 minus 7, which is x. So that way checks out. Now I have to do it the other way. I'm going to plug f into the inverse, which means I'm taking 5x minus 7 and putting it right there for x. So 5x minus 7 plus 7 over 5. These add to 0, so I get 5x over 5, which is x. So that's how I know I've done it correctly. Let's do this again on part B. Again, I need to rewrite this as y equals. Then step 2, swap my x's and my y's. And then order of operations. I have to multiply by 5. And then I'm going to divide by 4. And so y equals 5x over 4. So my function notation, f to the negative 1 of x, is 5x over 4. Now I'm going to go ahead and do my composition to verify that I did this correctly. I'm going to plug my inverse into f first. So 5x over 4 is going to go in right there, 4 times 5x over 4 divided by 5. These cancel, so 5x over 5 is x. Then the other way around, we're going to take 4x over 5 and plug it in here. The 5's cancel. 4x over 4 is x. So I have done that correctly. Moving on to example C. Again, first thing I'm going to do, write this as y equals notation. Then I'm ready to swap my x's and my y's. And then getting y by itself. So first I need to subtract that 3. And now y is in my denominator. And so to get it out of the denominator, I'm going to have to multiply by y on both sides. So I'm going to have y times x minus 3 equals negative 6 over 7. And then to move the x back to the other side, I'm going to be dividing. So it's just going to go into my denominator. And so my inverse, f to the negative 1, is negative 6 over 7 times x minus 3. Now you could distribute out that 7 into the bottom, or if you leave it like this when we're doing our composition to verify, you're going to see that it's actually going to make our math a lot easier. So on to step 5, verifying with composition. I'm going to plug my inverse into my initial equation first, so f of my inverse. So that's going to be negative 6 over 7 times negative 6 over 7 times x minus 3 plus 3. So because I kept that 7 out here, I can see that this is easily going to cancel. And so I have negative 6 over negative 6 divided by x minus 3. So I'm dividing by a fraction. So remember, when we're dividing fractions, we're going to do keep, change, flip. So this is the same thing as negative 6 over 1 divided by negative 6 over x minus 3. So I'm going to keep, change, flip. And so those will cancel, and I'm just left with x minus 3. And then I still have that plus 3. So x minus 3 plus 3, those add to 0, and I'm left with x. Now let's do it the other way. Plugging my initial function into my inverse, and that's going to be going in the bottom here. So negative 6 over 7 times negative 6 over 7x plus 3 minus 3. So those cancel, the 7's will cancel, and so what I have right now is negative 6 over negative 6 over x. So again, that means I've got negative 6 over 1 divided by negative 6 over x. So I'm going to keep, change, flip. Again, those will cancel, and I'll just be left with x. Okay, last one, part D. This one's already written in y equals form, so I can go straight to step 2, which is swapping my x's and my y's. So I'm going to subtract the 2. Then I have to divide by 3. And then the last thing I need to get rid of is that square. The way we undo a square is by taking the square root of both sides. So the square root of x minus 2 over 3 is my inverse function. So there's my function notation. Let's do some composition to verify we did this correctly. Starting by plugging my inverse into the original function. It's going to be 3 times the square root of x minus 2 over 3 squared plus 2. The square cancels my square root. Those 3's cancel, so I have x minus 2 plus 2, which is x. Then the other way around, I've got inside my square root 3x squared plus 2 minus 2 over 3. So those cancel. My 3's will divide out, and I'm left with the square root of x squared, which is x. And that is how we find functions, inverse functions algebraically. Another way we can do this is graphically. So remember, we're switching our x's and our y's. So if you're given a graph, one way to find the inverse graph is to find some points on your graph, swap the coordinates of your x and y's, graph them, and connect the dots. So here I have a graph, f of x. I am going to color over it in green so that we can differentiate between our original and our inverse. And what I'm going to do is I'm going to go along here and just pick a couple points that I can easily pick out. Let's see, I've got one here, 2, 3. I want at least 5. So there's 1, 2, 3. Let's go back up. 1, 2 more. So I'm going to look at those ordered pairs. This one is negative 4, 4. This one is negative 2, 3. I've got 0, 2, 2, 1, and 4, 0. So what I'm going to do to graph my inverse is just take each of those ordered pairs and swap the x's and the y's. So this one's going to become 4, negative 4. This one becomes 3, negative 2, 2, 0, 1, 2, and 0, 4. Now I have 5 new points, and I am going to plot each of those. So 4, -4, 3, -2, 2, 0, 1, 2, and, oops, I plotted that wrong in the wrong place. There it is, 1, 2, and 0, 4. Ignore that one was a boo-boo. And now I can just connect the dots in as straight a line as I can, because I'm freehanding this. And there is my inverse. It's that easy. You're just swapping the x's and the y's. Let's do this once more. This time I'm given the equation. I don't have the graph already, so we have to find some different points. So if my graph is, or my equation is 2x minus 3, one that I can easily plug in is 0. And when x is 0, I know that my y is going to be -3 because this is slope-intercept form, so I know my y is -3. So let's just get a good variety of values here so that I've got some positive and some negative. If I plug in -2, 2 times -2 is -4. -4 minus 3 is -7. If x is -1, 2 times -1 is -2, minus 3 is -5. If I plug in +1, 2 times 1 is 2, minus 3 is -1. And if I plug in 2, 2 times 2 is 4, minus 3 is 1. So I'm going to go ahead and plot those points that I've just listed. And again, I'm just going to connect the dots as best I can. So there's my initial graph. Now to do my inverse, I'm just going to swap each of these ordered pairs. And plot my new points. And then again, connect the dots. It's that easy. All right, and that concludes our notes today on finding inverses both algebraically and graphically.